we are going through the fourth thing. And this fourth thing, what does it say? It says recognize and integrate. This is, we've done 1, 2, 3. Now we're at 4, of course, which says now recognize an integrand of this form. Okay? This form. In other words, an integrand is something which we are about to integrate. Okay? Right. So, and they say and integrate such functions. So let's work through this. We want to be able to integrate something in this form, and here are the examples they've given us. So if you watch the video which I made at the beginning, I talked about how there is algebraic substitution, but I'd like to alter that a little bit because this is going to, we're going to use logarithms here to differentiate this thing. We can use u sub, but we use u sub when we have something with a power outside, like there's another power outside. This will be the derivative of the bottom, but then there will be a power outside, like to the power of 7 or to the power of 5, and then we can be able to use u sub. We can also use it here, but either way, we are going to work with the logarithms. That is what we work with here for our A level. So let's go ahead and let's work with the logarithms. So what are we going to have now? Let's work with it. So if you remember, on our common derivatives table, we say that when you are differentiating ln x, let's talk about the derivatives of ln x. What is the derivative of ln x? It is 1 over x. What about the derivative of ln f of x? That's the one we care about so much. Okay, we know that you can do it by knowing that, okay, this is now a composite function because f of x is inside and ln x is outside. So we said a composite function is when you have it not being an x, but being something else which is not an x. That is what f of x is representing here. It's representing something which is not an x. So f of x is representing something which is not x. Whatever it's going to be. 3x squared plus 5 or whatever, we don't care. Even if it's sine x or whatever. So in this case, what do I get if I differentiate something which is ln, something which is not x? ln and then something which is not x. What am I going to do? Well, we start by differentiating the outside. If you differentiate the outside, ln just stays 1 over. So in here, it will be 1 over f of x, okay? Because this is no longer x, it's an f of x. So it becomes 1 over f of x. Then we differentiate the inside. The inside is the f of x. So we then multiply by that, which is the derivative of the inside, right? We then multiply by the derivative of the inside. And we like to just write it to say it is the first derivative. It's the derivative over the original function, okay? If you're getting ln of some function, you just differentiate that function and then you put it over its original. That is going to be the derivative. That's going to be the derivative, not ln of x, but the derivative of ln f of x. This is what you get. Now, that's the same principle we're going to be using here when we are integrating. Because we are now integrating, we said we are integrating something which is k f prime of x over f of x. And we are integrating it with respect to x, which is the derivative over the original function. That's what we are doing here. The derivative over the original function. You say to me, but there's a k now. There's a k. There was no k. And yet, no, k is a constant. And we said when you're differentiating or integrating, a constant which multiplies is just thrown out, okay? It doesn't change anything. So this k is just going to be thrown out. So it is k times the integral of f dash x over f of x, okay? With respect to x. So k doesn't change nothing. It doesn't change nothing. So the answer will be k. And then what is the integral of this? We are going back where it came from. So the derivative took us here. So integral should take us back here. What is that? ln x. So it'll be k ln x. Okay, but remember to put the modulus. Remember, so this is not ln x, but ln f of x. Remember to put the modular signs and then say plus constant of integration c. And this would be our solution for this. So we can say now the integral of k f prime x over f of x with respect to x. What is it that we have seen so far? What are you just going to do? K just comes, okay, you factor out k. You factor k out, okay, of the top. Why is k there? Because it's there to make the top be exactly the derivative of the bottom. So you factor out a number which makes the top be the exact derivative of the bottom. So now you'll be having k, and k is now going to multiply ln in modular signs. We put our f of x. Then we say plus constant of integration c. And this is going to be weighted. Now we're going to do several questions in the next video where we see how we practice this, beginning with the ones in your syllabus that we've just seen. There's two, x over x squared plus x and tan x. Maybe we can even try one now. Okay, let's do worked examples. So you can say worked example 1. Okay, worked example 1. We want to find the integral of x over x squared plus 1 with respect to x. So this is you. Okay, you're supposed to find the integral of x over x squared plus 1 with respect to x, right? How am I going to do that? Well, this is so easy because you look here and you analyze, and you're going to see that the top is the derivative of the bottom. If I look here, if I differentiate x squared, the power reduced by 1, it will become an x, right? Exactly. And if I differentiate 1, it goes. So the powers on the top just must be 1 less than the ones on the bottom. So yes, I can see that. So now I can say, okay, the top is the derivative. So I can now say, for this, I'll say, when you're integrating this, you say, let f of x, okay, so we are saying for the integral of this, you say, let f of x be equal to, our f of x is going to be the bottom, x squared plus 1, okay? Which means now our f dash x is going to be, if we differentiate x squared, what do you get? You get 2x, okay? The power, you drop down the power, you reduce it by 1, you get 2x. Differentiate plus 1, you get 0, so it's going to be 2x, right? Now, we have to make the top and the bottom be the same. Remember that. That's the biggest rule. You have to make the top and the bottom be the same. Now, here, the derivative of the top, what is it going to be? The derivative of the top is at 2x. So we need to make this at 2x. And how do we make it at 2x? It's very easy. So we know that the top has to be 2x. The bottom has to be x plus 1. And the top is just an x. So we can now say the integral of x over x squared plus 1 with respect to x is equal to, you can say the integral of, we want this to be at 2x. If you want it to be at 2x, you're multiplying it by 2, right? And how do you reverse that multiplication? You divide by 2. So we're going to divide by 2, and then we are dividing 2x, okay? So we make it a 2x. In other words, we multiply it by 2, it becomes a 2x, but we put a half outside to remove that 2x. And this is going to make, the bottom will remain as x squared plus 1, and with respect to x. So it's like, if I say times 2, then I say multiplying by half, I've done nothing. So that's what had happened. Now I'm just going to bring the half outside. The half, then I have integral of 2x over x squared plus 1 with respect to x. Now it's already meeting the fx and f dash x. Okay? It was already meeting. You didn't even have to take half outside now because we had it as the k. Our half was the k. But anyway, now we can know that, okay, the top is the derivative of the bottom. What are we going to use? ln. So it's going to be half ln of the bottom, which is going to be in modular signs, x squared plus 1. Then we say plus constant of integration, c. And this is going to be the final solution. And we would be done with this one, okay? Now, the last thing which I'll do is for tan. So worked example 2 in the next 2 minutes. I need to be finished in a few minutes. Worked example 2 now, we're doing for tan. So it's the integral of tan x with respect to x. How do I integrate tan? My friend, if you look at derivatives, we had the derivative of tan, but there is nothing that we differentiated and gave us tan, okay? We had, let me put it, it's y and dy dx, right? If we differentiate tan, what did it give us? Sec squared x. When we differentiated sec, what did it give us? Sec x. It gave us sec x tan x. So if you see, there is nothing that we can differentiate to give us only tan. That is not going to work. So how do I integrate? Because integrate is moving backwards. How do I move backwards if there is no tan on these derivatives? That there is no derivative which gives you tan. So if there is no tan, then how should I do it? How am I going to win now if there is no tan? Well, you have to change tan to what? To sine over cos. Tan means sine over cos. Okay. If you don't know this, tan x means sine x over cos x. Okay. You have to always write them as functions. Okay? Sin x over cos x. If you don't know this, you can go and check your trig. You'll see that. So sine x over cos x. This is my tan. Right? And then what am I going to do? Now I have the top being the derivative of the bottom. If I differentiate cos, I get sine. I get negative sine, which is type of the top, okay, which is similar to the top. So since the top is the derivative of the bottom, I can use ln. But remember that we always need to make them exactly the same. So we're going to say, let f of x be the bottom, which is going to be cos x, okay? We find the derivative. F dash x is going to be equal to negative sine x. So now we know that if this is your f of x, then the bottom should be a negative sine x. And how are you going to make sure that happens? You're going to introduce it at the top. So you can now say the integral of tan x with respect to x is going to be equal to the integral of sine x over cos x. And it's all with respect to x. Now, what am I going to do now? Well, what you're going to do is you have to make the top be a negative. So how do I do it? I bring a negative outside and one on top. So it's going to be negative. You can put a negative 1 times negative sine x. So we've made the sine x be negative, but we've multiplied again by a negative 1, which makes it positive now. And it's over cos x. And we are doing the integral. And it's with respect to x, right? And then now what are we going to do? We bring minus 1 outside. So minus 1, the integral of negative sine x over cos x with respect to x. There's going to be minus 1. And then now, what happens here? Well, since we know that the top is exactly the derivative of the bottom, we're going to make it ln. So it's minus 1 is going to multiply ln of the f of x, which is the bottom. Ln of cos x. Then we put our constant of integration c, and this will be everything, and we would be done. We would be done. So I'll do more examples. This is not the end. I'll do more examples in the next video. Goodbye for now. We will meet again in the next video.